Okay, thank you very much. So, hello everyone. I'm Lu Xiangzhao. So our project is part of the Quack's funding on the resourcing decarbonization. So, looking at the circular economies of climate-induced innovations in the many regions. So it is based on the context that the transition to clean energy is driving a sharp rise in the mineral demand. So it's creating a supply gap, and we're also intensifying the environmental and the social pressures. So our project aims to explore ways to responsibly address the emerging supply gap of the critical minerals. So our project has two parts. So I will firstly briefly introduce the part I'm working on with Dr. Eva and also Professor Karen, that's looking at developing the circular economy business models for the mining sector. And then I will hand over to my colleague Juan, who is looking at the building economic case study on the oil sand. So our project is looking at developing the circular economy business models for innovative mining and for repurposing the mine waste to addressing the emerging supply gap and also contributing positively to the local regions and communities. So this is to go through the literature reviews, to conducting the interviews with the industry and also the key stakeholders, and also to conducting some team workshops to help to developing such a framework. And the expected impact is can help the mining companies to better to improve their decision making in formulating the circular economy strategies, the implementable actions, and also the circular economy performance indicators. So from the literature review, we have found out that the mining sector specific circular economy principles currently is underdeveloped. So we have been looking at the literatures from the academic and the industry to draft a set of 5 circular economy principles in the mining context. So firstly, to maximizing the renewable inputs, so that is about to reduce the use of the virgin raw materials through the circular sourcing, and secondly to minimize the waste and the impact in the production process. So this is focusing on the efficient use of the minerals, the materials, energy, and water. And thirdly, to maximize the use of the waste and the byproducts. So this is to transform them into valuable inputs so that can enhance the resource efficiency and also to improving the material traceability. And fourthly, to maximize the product reuse. So this is about to extend the life cycle of the mining mining equipment, and also to promote the remanufacturing and also the adaptability in products. And finally, to creating the social value. So this is about to ensure the mining activities contribute positively to the environment and also the society by planning for the progressive rehabilitation and community prosperity, the biodiversity conservation, and also to promote the responsible consumption practices. And for the circular economy business models, so there are 5 typical archetypes of the business models that have been commonly used across the sectors, but they are mainly developed and applied by the manufacturing sectors with limited work on looking at the mining sectors. So from these 5 typical architectures, so the circular supply and the resource recovery are most relevant to the mining sector. And the product service systems also hold high potential by providing the resources, services, opportunities. And beyond those typical archetypes, we also identify some additional subtypes from the literature in the mining context. So including the repurposing the post-mining sites to developing new products, and also the decarbonization and the pollution control, and also the efficiency-oriented innovations. So these business models they are helping to provide the insights to tailor the business models in the mining context. So the business model it provides a rationale of how a company that is creating, delivery, and also capture the value through these sub-elements. And we are currently conducting the interviews to better understand the opportunities and the challenges for shifting towards the circular economy business models in the mining sector, so that can help to explore the different pathways and also to develop the implementable actions and performance assessment indicators. And this table shows the current key findings from our ongoing interviews. So firstly, in terms of the circular economy concept adaptation in the mining, we do find out that the mining companies, they do see the growing importance of the circular economy as a key for the economic gains in the long term, and also the sustainable mining. And they also having the diverse views and understandings of the circular economy. And many circular economy aligned practices are already existing in the mining, but without being labeled as a circular economy, because they follow the efficiency and waste reduction logic. But currently, most of those practices are largely linear and back-end focused, and there is a lack of the system-level thinking. And in terms of the key opportunities, so people, they do see the potential of the future demand of the circular materials, and also the potential of retain the material ownership and control. And in terms of the challenges, so there's about the mindset change, the upfront investment, and also the evidence, the business case to as the key to facilitate. And also currently, the circular economy is more considered as a concept to be integrated within the existing projects rather than a split business model. And what has been continuously coming out from the interviews and have been highlighted is that the making money is the bottom line, and there is a need to demonstrate the additional or equal benefits of the circular economy practices. So this highlights the need of a strong economic case to facilitate the circular economy adaptation. So now I'm going to hand over to my colleague Juan, who is going to provide an economic case study on the oral sand.
Thank you. Well, as Longshan mentioned, this presentation is much more particular to the case of Orsan. So this is in collaboration with Daniel Franks and Juliana Segura Salazar from the Orsan Knowledge Hub. So we try to start building an economic model that can handle these kind of questions that we discussed previously, like it is profitable, like secondary production for the recovery of critical minerals, etc. So we started with the case of Orsan because it was straightforward and from all the knowledge that was already built at the Global Center for Mineral Security. So we, in the context of this growing problem of mine waste, that is aggravated by decreasing in ore grades and the demand for these different commodities, has associated huge environmental impacts and risks for local communities, and there is a need for more information about if all these different options that we have discussed has some what is the economics behind of that. So we explored the case of Orsan. Orsan is taken from the unutilized materials or waste rock from the iron and economy. It's not geology is not my background, but our sand came from the unutilized material from waste rock. So it's not taken from tailings. That is an important distinction, and has the ability to substantially reduce the amount of mine waste that is being generated. So it's more of the economics, the profitability of the adoption of our sand will come from that side. So we developed an economic model and calibrate it with the case of an iron ore mine with S&P data to quantify the economic profitability of the adoption of our sand. There are key advantage of taking an economic model. This is not a financial model. It's not like a business model, but it allows us to derive like mathematical analytical results that can be generalized to different other contexts, not only with the case of iron ore that we use the data from, but can also be extended for other contexts or other similar technologies of secondary processing. And also allow us to explore the implication of various sources of uncertainty that we discussed before, like price volatility, but also there are uncertainties because these technologies are developing, so we don't know exactly also some technical aspects, so we play a bit with uncertainty in cost and also uncertainty in revenue. So, and we tested sensitivity a lot of different scenarios for our sand adoption. So some key elements that the model includes is that our sand has production reduced mainly. A lot of the economics come from the reducing in rehabilitation and tailing management costs, but there are also technological complementarities between primary and the secondary production. So we use the case of an iron ore mine, it's Brucutu Valley in Brazil, taking data from S&P from 20 years to calibrate this model. And essentially we assume that it's a new operation, so they are building the circuit for secondary production from the very beginning. And you will imagine that the decision to adopt our sand came if the mining company is being able to cover the fixed cost of adoption. And on the other side, the amount of our sand that is produced every year comes from the relative marginal cost of secondary production relative to primary production. But a key insight from this model is that as long as these secondary circuits are not so large in relation to the primary operation, all these different uncertainties do not play a key role driving the profitability of the mining operation. So that is an important result. So as I mentioned, we calibrate this model to match data, the scale of the operation of the Brucutu mine that is already producing our sand over about 20 years from its beginning. And you can see here some of the costs associated with capital, labor, energy, and other materials for the business as usual scenario and also from the adoption scenario. So we have some assumptions related with the scale of production of our sand, and here these costs are in relation of per ton of unit of production of equivalent units, so our sand in equivalent units of the primary production, that would be iron ore. So that is the scale of the primary commodity and the scale of the secondary commodity over the life of the mine. And then this is the profitability also over the life of the mine. So you see here in your left, you see the profitability of the business as usual scenario for this mine and the adoption scenario. And in your right, you see the different scenarios of rehabilitation costs. So because our sand can reduce, depending on some technical stuff, it can reduce rehabilitation tailings, so up to a certain extent. So business as usual scenario is about 1.6 billion on average across all the different simulations. And even in a situation in which our sand is not commercialized, it's not sold for profit, but the mining company is paying for the transportation costs up to a certain point. So there is still gains of profitability. As you can see that this very conservative scenario of about 10% of reduction in waste management and rehabilitation costs is about 1.9 billion for the overall 30 years of the operation of this mine. But you can see as the more optimistic scenario of when ore sand is commercialized at the market price, you have price volatility here. So that is the difference between the different scenarios as well. So you have price volatility also in the ore sand, and you have in the more optimistic scenario of 50% of waste management and rehabilitation cost reduction, 2.3 billion. So, but we have played with different functional forms for the production functions, for the profit, as well as how these gains are distributed over the life of the mine, but still these results are robust to different scenarios. So we analyzed the economics incentive for this adoption of large volume sand byproducts. The advantage of this model that we are already generalizing this model also with the case of copper production in Mount Isa. But it has that advantage that allows flexibility. But we need, as we get more data, we also improve the calibration of the model. But the important is that there are qualitative results and quantitative results. So the qualitative result is that despite the different role that play different parameters in the model, you can see that still the cost savings entailing waste management and mine rehabilitation offer robust economic incentive for the adoption of ore sand. But there is the quantitative result of to what extent these gains are, as I mentioned before, but that depends a lot on the different contexts. So thank you.